As you can see, we have three vectors. I'm gonna go by vector each time, and we can see the vectors and we're getting the magnitude, and then we go all the way and use the dot product. So you have the Cartesian coordinate system, x, y, and z hat for this one, and z hat comes out of the board because you have x and y vector, and it's kind of like, taking too much time to do 2D, so I'm gonna do 2D. And then we're gonna have, for example, they say graph table, and then we have 3x hat because there's 3x hat. We go that way, and then we go negative 2y because you have negative 2y, so if the y goes up, then negative 2y has to go down, and we have vector A. And this creates, because there's a very larger angle, I'll say there's a 30 degrees angle on the vector A. So you have the 30 degrees angle with the coordinate system. And then on the other hand, we can get the magnitude. So the magnitude, we get the components on, and we get square them on, add them on, and then get the square root. So we can get the square root of 13 for the magnitude. And that's how we get vector A out of the board, and we can see, okay, there's our scalar. So because I have unit vectors, they are not a scalar, but then we get the scalar because of the magnitude. And we can see how they are different and using different symbols, because we don't have any symbol right now because we're given for a scalar, but we have x hat and y hat for components and the vector that we have. So now I'm going to go to vector B and C and see what we can get. The same thing goes with vector B, and we have the direction, which is going to be like, go up, south, north, east. Last one we had like a southeast stuff, but we have, for vector B, we have a y hat and a z hat, and then we have the Cartesian coordinate system, x hat, y hat, and z hat, but we have z hat going to the right, y hat going to the up, and then x comes out of the board because you have y hat and z hat, and they're both positive, so B hat goes a very narrow, straight, long, straight direction. I have 45 degrees angle because this, I think it does perfectly 45. Look how it works out. And then we also have the magnitude, which is going to be square root of 164, because we get 10y hat squared plus 8z hat squared. Add them on 164 and then square root of that, which is going to be like 12.81, but we're just going to stick with square root of 164. Let's go get the next one. So vector C is going to have a negative 5z hat. Excuse me, my mark is not right. And then negative 3x hat. So we're going to say, okay, Cartesian coordinate system again. But we're going to use that Cartesian coordinate system that's going to match our vector C. Z hat going up, x hat going right, y hat comes out of the board. Now we're going to the opposite direction. We're going to have negative 3x hat and then negative 5z hat to get vector C. And the vector C is going to be giving out, I can about 40 degrees over here. So that's a 40 degrees angle. It's going like a southwest. So we are going to say, okay, we're going to get the magnitude. I'm going to say negative 5z hat squared, negative 3x hat is squared, square root of that, and then we're going to square root of 25 minus 9, square root of 34, 5.8. So that's we get it, and how we have the difference of the vector and scalar. And now we're going to go and get the scalar. I'm going to get two magnitude of these, and I'm going to see like how different they had. So you had like 40 degrees, and then we had some other angles like that, and we're going to get one dot product just to prove that we also have done a dot product to get this pretty much straight, and see if we can have a very great dot product and stuff like that to get that straight. Now I'm going to use vector B and vector A as the vectors that we have, and we can say, okay, we had the magnitude, so let's get a dot product. So we had the components, and we get the magnitude from them, and we're going to get the dot product because it gives us a scalar. That's a unit vector, so we're going to get out the unit vectors and get magnitude and get the scalar. So that's what we're going to do, and dot product is going to see, okay, we're going to get this square root of 164, square root of 13, we're going to get cosine of 75 degrees, and then we get 11.95. When I get 75, I just add the two vectors. We have 45 and 30, so we get 75 by adding them. This should be true because it's acute, so we get a positive 11.95, and that's how we get the dot product. Hopefully you guys learned something new, and if you have any questions, let me know in the comments.